Okay, so here we have a reaction, and we're in elimination substitution, right? Um, so this is an example of an E1 reaction, but let's say we didn't know. Okay, just like E2, just like all the other problems, we have to we have to break it down, right? So I have some stuff written up here. Okay, I'm gonna explain to you why I did this. All right, so I'm gonna use this burnt orange. Okay, so again, we gotta identify alkyl halide. This is a secondary alkyl halide. Okay, doesn't really give us any. It doesn't really give us like a definite, but we need to consider that. Okay, then we have water. Water is going to be a weak base and a weak nucleophile. It's just neutral, so it's going to be weak on across the board. Okay. Then we have heat. If there's heat, it's going to be elimination, right? You're going to force that elimination reaction. So we have a secondary alkyl halide, a weak nucleophile, and a weak base. Okay, so let's think. SN1 reactions happen in the same environment E1 happens. E2 reactions happen in the same environment SN2 reactions happen. Okay, so we have a weak base, weak nucleophile, and a secondary alkyl halide. Okay, SN2, we know it's elimination, so all we have is E1, E2 to decide between. But E2 would need a stronger nucleophile, right? But E1 can deal with a weak nucleophile or weak base, weak base in this case. Sorry, when I said E2, I meant base. E1 can deal with a weak nucleophile or weak base. E1 can deal with a weak base because the base strength doesn't matter, right? Whereas for SN2, E2, the strength matters, right? So for SN2, you want a strong nucleophile. For E2, you want a strong base. But for SN1, you can have a weak nucleophile. For E1, it's a little similar, right? So because of all those things, we can eliminate E2 being the option because this thing's just too weak, right? And we have E1 as our only option. So let's go to the chart and see if that logic was correct. I hope I was right. Okay, so secondary alkyl halide, weak nucleophile, weak base with heat. It's up here. Secondary alkyl halide, weak nucleophile, weak base with heat. And that is an SN1 or E1. Again, there's heat, the temperature's high, so it's going to be E1, right? Okay, so now let's do the reaction scheme, right? Okay, so the rate determining step that bromine's going to leave. Then you're going to have your carbocation, right? And this is E1, so again, we need our beta hydrogens and beta carbon, right? So the carbon bearing the leaving group was the alpha carbon. And then we have our betas, right? Remember, on the beta carbons, there's beta hydrogens. And those are the ones we're going to pull off. Okay, so we have water. Water, right? Yep, chilling. And this water has a decision to make. Okay, I'm just going to get these beta things out the way because we know they're beta hydrogens. This water has a decision to make. Which hydrogen will it pull off? This one or this one? Okay. So I didn't specify, but we want the major product, right? We want the major product for this reaction. I meant to write that. So we want the major product, okay? So the major product for an E1 reaction will be an alkene that is more substituted, aka there's more carbons connected to it. So of the two options, the option that has the best success, as far as when I say success, I mean the option that's going to give us the most substituted alkene is this hydrogen, because those bonds are going to go here, right? Making this, versus this one, right? If we pulls that, we'll make that, right? We see a di substituted and a mono substituted. Oh, mono substituted. Okay, so this di substitute is going to be the major product, aka the right answer. So let's look for it, and we see it right here. Right, the answer choices here. A and B were like the competition answer choices, right? C makes no sense, right? D makes no. C and D are this just to throw you off with SN1, E1, stuff like that. Sorry, SN1, SN2, right? That's substitution, but there's no reason for those. Okay, once you take your time, the answer choices don't scare you. Okay, so let's go through this again. We want the major product, right? We have a secondary alkyl halide. It's a good leaving group. We have water, and water is a weak nucleophile and a weak base. And we have heat. So we put those together. Weak nucleophile, weak base. I'm thinking E1, SN1 simply because it's not strong, right? Then we have heat. If there's heat, you force elimination. So I'm thinking it's going to be E1. Right? I don't think it's going to be E2. E2 happens in the same environment SN2 happens, and they like those strong nucleophiles, right? Slash strong bases, okay? But this is weak, right? So I go to my chart, double check real quick. Secondary alkyl halide, weak nucleophile, weak base, and it's hot, so it's going to be E1, okay? If you reference this chart as you do homework, you won't have to reference this, but we're going to think this through instead of just going to the chart. Okay, so thinking E1, right? We've confirmed it. So let's just perform the E1 reaction. First step, bromine leaves, creating a carbocation. Then we got to name some stuff just to keep our bearings, right? We have the alpha carbon, the carbon that had the leaving group. Then we have the beta carbons. Those are the carbons connected to the alpha carbon. On the beta carbon, you have beta hydrogens. Those are the hydrogens you're going to pull off for any elimination reaction, okay? And here, the bromine left, so water comes around, floating around, and now it has a decision to make. Which one's going to pull off? Well, this reaction is going to pull off both, but we're looking for the major product. And the major product of an E1 reaction will be a more substituted alkene. So we find the hydrogen to be pulled off to be this one as the major product. So you're going to have more of that happening than the mono substituted product, which would be this one getting pulled off. Okay, so we have our major product, and now we look to see if it matches, and we have found a match, and that's our answer. Again, these are E1 reactions, just step by step, not that bad.